Gaurav Tiwari. I belongs from Akodhigola, Dairy Onson, Rohtas, Bihar. Now I am doing my MCA from Gopal Narayan Singh University, and today my topic is 2-bit and 4-bit comparators, and my first slide of my topic is that 2-bit and 4-bit comparators in computer architecture, and my next slide is Introduction to comparators. Definition: a comparator is a digital circuit that compares two binary numbers and determines the relationship between them, greater than, equal to, or less than. Uses: frequently used in arithmetical and logic units, important for decision-making process, and found in many applications including embedded systems, processors, and digital signal processing. And my next slide is that comparator types. 2-bit comparators compares 2-bit numbers. 4-bit comparators compares to 4-bit numbers. Multi-bit comparators comparisons of larger bit width number using combination of smaller comparators. And my next slide is that bit comparator design and truth table logic equation and their examples given below. And my next slide is 2-bit comparator circuit cymatic use and or and XOR gates to create the necessary logic. Comparators usually require XOR gate for equality checks and OR gates for greater than or less than conditions. Diagram. So the circuit diagram for a 2-bit comparators. Sorry, in my slide the diagram is not definable. So sorry for this. And my next slide is that a bit comparator design truth table logical equations given in this slide. You can see this. And my next slide is 4-bit comparator circuit cymatic. A 4-bit comparator can be built using two multiple bit comparators in a hierarchical structure. The MSP is compared first followed by the next bits if the previous comparison is equal. Diagram. So the cymatic for a 4-bit comparator using smaller comparators. And my next slide is application of comparators in arithmetic units used in comparison of result from arithmetic operations like addition or subtraction and sorting algorithms. Comparators are crucial in sorting data in branch instructions for processors to decide whether a branch should be taken, in signal processing, in thresholding operation for digital signal applications. And my next slide is performance consideration. Speed. More bits mean more logic gates and potentially slower performance. Complexity. Larger comparator require more gates but can be optimized using parallelism or specialized hardware. Power consumption. More gate more gates typically result in higher power consumption. And my next slide is conclusion. Comparators are essential building blocks in digital systems. Understanding 2-bit and 4-bit comparators helps in designing more complex digital circuits, including arithmetic and logical units, and decision making units. Optimization can help balance speed, power, and complexity in practical application. And my last slide is thank you. Thank you everyone for giving me your time. Thank you very much. Thank you.